third video clip in a series of three which talk about our BEN simulation software. Recapping, the BEN simulation software allows you more productivity for your machine, your press brake. It allows you to import flat files to create 3D simulations, and once you have those simulations, you can then graphically program your machine. We'll also touch a little bit about the optional solids unfolder module. Today's topic, Part 3, BEN simulation software, inputs, and CAD conversions. Here's our agenda. We'd like to talk about creating the part file, the .part file, which is the 3D representation of the part that you would like to make. You'll recall in the other video clips we talked about the part file, but we never really touched on how to make that. And there was a reason for that. We wanted to divide the process of programming from the process of converting and making that part file. And that's what that conversion process is what we're going to cover today. So we're going to do it a couple ways. The first way is we're going to make a part file from a flat by using a flat DXF or DWG or IGES file. We're also going to make a part file from our optional solids unfolder. And in this case, we're going to bring in a solid model and convert that. And that model can be in an SAT format, which is the extension on a traditional ACES format, a step file, or an IGES solid. And the solid model unfolder can work with most native solids. Next, after doing that, we're going to talk about something else. We're going to talk about creating special tool files from a DXF. You may be working with a press brake tool manufacturer that's making a special tool for you, and with that, they can give you a DXF file of the cross-section. We'll talk about making that conversion and adding that to your tool file. Lastly, we're going to talk about some additional techniques in the tool file, possibly dealing with sectionalized tooling and how to add those sections. And then we'll have a little wrap-up at the end. Okay, let's get started with creating a part file. With Cincinnati's BEN simulation software, if you go over here to the upper left-hand corner and go to File and New CAD Part, you'll notice there are a number of options that are available. 3 of these options are available as a matter of standard course with our BEN simulation software. The 4th item is an optional feature. So let's talk about those. If we're going to create a part, we can draw a cross-section, we can draw a flat pattern, we can import a flat file, a DXF or DWG or IGES file, or in an optional way, if you were to purchase our solid model unfolder, you could convert a solid model here as item number 4. I'm not going to spend a lot of time today on drawing a cross-section or drawing a flat pattern, but with both of these methods, you have the ability to make a very simple Cincinnati part file that allows you to graphically program. The draw cross-section system just allows you to essentially make a gutter or channel or item like that without end pieces, and then extrude those out into a long part. The draw a flat pattern method allows you to dimension a flat pattern, and with that you always will receive notched corners at each one of the corners. When you take it further by adding additional flanges or additional tabs, additional notching automatically appears. It's actually a very clever little way to do a rectangular part if you don't have a drawing system. But a 5-sided part or a part with holes, on these first 2 methods, those won't work. So for the most part, we're going to work with parts that you've already drawn in your CAD system and then converted to flats. Let's start with that, bringing in a flat file like a DXF file. I'm going to bring in a flat right here. Let's start with this part right here. Here's a very simple part, and when you bring in a DXF file, the first item that you can do is go into the drawing cleanup phase. Some of the DXF files that you might be working with might have a title block or a border. They might have additional views that you're not interested in. In this case, you can select an entity, and I'll choose this bend line right here. You can select an entity and turn that entity off, and then you'll only be converting what's remaining. So if you've got a title block, you can either select the lines in the title block or window in around that and eliminate that in this phase. I'll turn that bend line back on. Once that's done, you can then go into your conversion. One other item I'd like to point out on this screen is that you can eliminate certain things in mass if they're on drawing layers. For example, the bend lines here are removed with just the click of a button if those bend lines have been placed in the drawing on a different layer. Also, if you have a metric drawing and want to convert that, this is the area where you would do that. These drawing units here are imperial or English, and I'm not going to make the conversion, but here is where you can do that. And also, some flat files aren't at a scale of 1. They might be half scale or they might be double scale. At that point, you can make the change here to make sure that your 3D representation that we're going to make will be exactly full size. Also, if you need to measure something in the flat, we've got a little ruler here that you can stretch a ruler across something and measure it. So now that the drawing is cleaned up, we'll proceed. We'll go to next. And at this stage of the game, we're going to specify the bend lines because the software at this point can't recognize a bend line from any other line on the drawing. So what we need to do is decide what we're actually going to do with the bend lines. First of all, some of the drawings that you might have no bend lines at all, and you may have to add those. And in that case, you would select this radio button right here, and you can add a bend line. Now, this drawing does have bend lines, but let's add one just to show how that might be done. What you would do is you'd select a linear segment to use as a reference, and then what we would do is you would add the bend line and the bend angle and bend radius at this point. And here is a bend line that has now been added in a place on the DXF where there was no bend line before. You also have the ability, I think you saw it in that window, that you could actually have an offset angle to turn this bend line where it's no longer parallel to the reference line that you started with. I'm going to delete this bend line here, okay, and go into a more traditional way of converting the part by selecting the fact that the bend lines that are on the drawing are a single line at the center of the bend. Also, if your CAD system places your bend lines as 2 lines separated by a bend allowance, you can use that as well. But I don't have a drawing that shows that. So what we're going to do now is we're going to specify the bend lines and say what these bend lines mean. Okay, well, let's start with the up bends first. Here's a 90-degree bend. 90-degree bend means up, bending toward you out of the page. And we're going to look at our drawing. I don't have a drawing that I can show you in this video clip, but this drawing has a .063 inside radius on it. And I'm going to bend this 90 degrees up here. I'm going to click on this line here, 90 degrees up. It's just going to keep defaulting to the last one that I used. And this one is going to be 90 degrees up as well. This bend line is going to be 90 degrees down. So I'm going to click in the box, change my 90 to a 90 negative. And now I've got a 90-degree down bend line here. And I'm going to do the same thing over here. Now let's click Finish. When we click Finish, it asks us to choose the material type that we're going to use. I'm going to make this as a mild steel part. My material thickness, I'm going to go with 16 gauge on this material. I just click on my 16 gauge button. Now we'll click OK. And my part file now is complete. So this is the first part file that we've made by converting a DXF. At this stage, we can save that or continue programming it. And I'm just going to save this. I'm going to save this right to my desktop here. And I'll just click Save. So this part now is available for a continuation in our programming process. Now that we've made the conversion, it can be programmed in the office, or if it's accessible to the operator on the floor by way of a network machine, the operator can pull this down, choose tools, choose a bend sequence, and make a program. Let's convert another DXF file. Here's another one, okay? And again, you have your orientation now, you know your way around this, so we'll just go to Next. I'm going to click on this bend line right here and say this bend line is 135 degree, and it's a positive angle. That means it's going to come up and out of the page. We'll do the same thing on this one. This one will be a 90 degree bend, up and out of the page. And here's our second part file. I'll go ahead and I'll save that one. Let's do a third one. Let's do this box here. Okay, looks good. And I'm just going to go over here and select these as 90 degree bends here. We'll bend up the sides here. And then we'll bend up the ends. And there's our part. Okay, you might look at this part and you might say, hey, wait a minute. You know that white represents the top side of my part, especially if you're using PVC coated, and that's the way I label my colors in my bend simulation software. The white often will be used to denote the PVC coating on top, and then the gold is kind of like the dark or underneath side of your stainless steel material. Well, you can see I've bent this part improperly. Okay, so let's get our orientation, and let's try this one more time. Let's pull the DXF file in again. In this case, remember how I had bent everything upwards? Well, let's look at this flat with an eye toward the fact that we're looking at the white side or the top side of the DXF. Really what we want to do, instead of bending things upward, we want to bend them downward into the page. Oops. I'll go to my next page here. There. So really what we're going to be doing is doing negative 90s. So let's do negatives all the way around on this. Now let's fold it up. There. That's more what we're looking for here. So if this is a stainless part, this would lay on the laser or blank making machine like a turret punch press with the PVC coating up, and then this is what we're looking at inside the box. That would be the bottom side as it lays on the laser. Okay, let's do one more. Okay, here we go. Let's go on this one. Let's go to my next page here. We'll click here and just do a negative 90 here, negative 90. And see here I've got a part with a tapered flange on it. Again, if it were made out of stainless steel, the PVC coating would be showing here on the top side of the material. The underneath side would be here. Okay? So that's a very simple way of making our 3D conversions out of a 2D flat. Now, there are other ways to make parts like this, and this would be with our optional solid model unfolding system. And let's talk a little bit about bringing something in from a solid using the unfolder. When we go to File, New CAD Part, If we've bought the option, this fourth solution or fourth option becomes available to us. We select it, and the unfolder engine starts. And in this case, what we can do is we can seek out a solid model. And let's take this one right here. And here's a solid model of a part. Now, one of the big advantages of the unfolder is that if all of this idea of your part or everything has been incorporated into a solid, why do we have to make the solid into a flat to make it back into a 3D? The other thing is, in that process, a CAD operator or somebody who is going to generate the Cincinnati part file has just as much opportunity of bending a flange the wrong direction as a press brake operator does. And if they bend it the wrong direction and send it to the floor, the press brake operator will follow suit and create the part graphically from that. And what they do is bend the part the wrong direction in the virtual world, grab their real material with their real press brake, bend the part and form it in the wrong direction in the real world, and you have real scrap, you have virtual scrap that turned into real scrap. And I think the point I'd like to make is that when the part has been designed properly, it's nice to come directly from the solid model. Now, in this case, what I'm going to do, I'm going to use our advanced unfolding method here, and I'm going to choose the top side of the part that would be on top on your turret punch press, or the part that would be on the top with your laser. And that's denoted as green. The underneath side is blue. And what we're going to do here is we're going to unfold this into the proper blank, and that will appear over on the right side of the screen. And then we'll just bring that back to the bend simulation module. And you've been to this screen before, and you recognize what the green is. The green bend lines mean that somewhere along the process, they've been given the exact bend angle, bend radius, and so on. But we don't have to do that in our case because it all came from the solid. So we just click Next, Finish, and then OK. And in that very simple 3-click process, we now have our 3D part file directly from the solid model. Let's do one more. We'll do this one right here. This part's a little more sophisticated with a lot of entities and a lot of bending. And I'll just go to unfolding that. And I'm going to choose the top side. And now, after clicking unfold, we'll receive the flat blank over to the right side. There's our flat blank. We'll go back to the bend simulation software. Okay, and you recognize this process. Next, Finish. And we're going to say this part is a stainless steel part. And there we have our part file. So you've seen a way to create 3D part files from flats and 3D part files from solids. Now let's talk about some additional techniques. For Cincinnati's bend simulation software, most of the tools that you might purchase from Wilson or Wheela are already in the tool library of the machine, where you can select those tools and add those to a library that you create that has the tools that you have purchased. But every now and then you might have a tool that's a special tool that's created by one of those manufacturers, or it might be created by yourself or another manufacturer. But nevertheless, you've got a DXF file that is drawn of that cross section, and you can bring in a very accurate representation of that tool. And I thought what I would do is show the process of importing a tool file from DXF. Let's just go back to our home screen, which is the Run Edit screen of our software. And let's click on the tool library icon. Here's our tool library. And you notice there are a number of different choices that are on the left side of the tool library here. And what I'd like to do is I'd like to import a tool that's an upper tool, DXF. And when you do this, it's important that you choose whether you're going to be importing an upper or lower tool, because even though we're bringing in a DXF file in either case, there are a little bit different dialogue questions that go along with the import that deal with upper and lower tools. So it's important that you have the proper selection here. If I was going to bring in a lower tool, let me click on this. I would be reading lower tool before I click the import toolbox. This time I'm going to click on upper tool and then import tool. And I'm going to go here to a file where I've got a couple of tools, and I'm going to bring in this upper tool that we're getting a preview of right down here in the little preview pane. Okay, just like when you bring in a DXF file to create your part file, with your tool file you can clean up the drawing. There may be stray marks on this that you'd like to turn off. There may be entities that are going to cause some problems. At this stage you can do that. Now it's important that when you pull in a tool file and create it from a DXF, that you pay attention to this front notation right here, that this right here is pointing to the front of the tool. If that's not the case with your DXF, you can use these buttons down here to change that. This one will turn your DXF, and this one will mirror image your DXF down here. Okay, so let's move that so that we're having the front of the tool face this front location. The next thing we need to do is create a center line, because the software doesn't know where the center line of the tool is yet. So we click on create a center line, and in my software here you can see a dark blue line has been overlaid over the DXF, and that it actually looks very very close to where we'd like to be on this. And if it's not close, we can manually adjust it either direction here, or we can click auto locate right here. And if the radius is tight enough and the angle is tight enough, it does a very good job of doing that. Well, I'm going to accept this green location, this green center line location. And after we've created the center line, let's click next. Now we need to click on the mounting surface, the thrust point, that's where this is going to mount into the brake. Okay, and I choose this horizontal surface as that point, and this works well for Euro style tools and American style tools, but this doesn't work well for head mounted wheel and new standard tools. And that's where you would select this box right here and then select the thrust point as the top of the head mounting on the wheel of tools, and we place an offset in that so that the graphic looks correct as that wheel of tool is placed up inside the clamp. But in this American style example, we choose this horizontal mounting surface, a thrust point right here, and then we click next. And if there's an offset line, we create that. With precision tools, you don't have to worry about this, but with older legacy tools, you do. For example, if the tool is made on an older planer, the center line of the punch may be a 64th of an inch, as much as a 64th of an inch off from the center line of your mounting tang. And if you'd like to correct for that, you can. And the nice thing about our bend simulation software is that if that correction is made, that correction stays with the tool file. And if this tool is put in forward, that correction then offsets the back gauge so that you have an accurate flange with that offset taken into account. And if the tool is inserted backwards, because you have geometries of parts that require that the tool be put in backwards. The offset then is applied to your back gauging dimension in an opposite direction because you've turned the tool around. It works very, very nicely on that. But in this case, I'm not going to create an offset line and click Finish. And you see the geometry of the DXF has now been brought into our tool file. We're going to put the angle on this. It did not read that from the DXF file, but it was a 30-degree angle. Also, the maximum loading, I know this tool is permitted to be 20 tons per foot, but if you don't know what the tooling would be rated for, our manual in Chapter 7 of our operator manual gives guidelines for assessing tool loading, and I would refer you to that. But then put in your tons per foot, and then also put in the radius. This is a 30-second radius. I'll put an 031 in there. So now we have our tool created. We've got our tool name. I'm going to add an additional part to this name. I'm going to say it's this number plus the word test. What if this tool is made in a segmented fashion? This number, by the way, is a Wilson tool number. So let's pretend like this is a Wilson tool special. I'll click the segmented box here, and then now we can add a set of segmented tools. And in this case, this would be a Wilson American design. So I'm going to add an X section. And the X section gives you all the small segmented pieces that allow you to make multiple lengths or very unique lengths of parts. To that, I'm going to add an L, which is the long segment, which is about 3 feet long, and also the S, or short, which is half of the 3 foot long piece for 18 inches. So once I've got my segments put in, this does two things for me. One, it allows me to have a completed library, but the other thing it does for me is it allows me to use the auto calculation feature. Once I know the length of a bend, I can double click on the tool and choose auto calculate, and it will calculate and choose the proper length of segments needed to make that bend. So I'm going to save that at this point, and then in my tool library I've added 50360 test, and here's my tool, and it's going to list the length of that no longer as a 24-inch length segment of, or length of tool. It's going to show that as segmented, which will allow us to use the auto calculation feature. There are many more things that you can learn about importing DXF files, importing solids with our optional solid model unfolder, different things you can do with specialized tools. All of them will be covered in Cincinnati's training class, and we do training classes at Cincinnati Incorporated at our factory. Here our trainer is pointing out something on his large screen while people at their own workstations are viewing the very same thing on their own workstations. This is a really nice setup for allowing people to do some things on their own, but then also work together as a group. Finally, I'd like to summarize what we covered in the short video here. We talked about creating the part file, bringing your idea of the part that you'd like to make into the Cincinnati 3D format. And we did it two ways. We did it by using a flat file and then forming that up, and we did it by using a solid model with our optional solid model unfolder. We also talked about creating special tool files from a DXF, and then we used the additional techniques of adding segments. Lastly, I'd like to talk about where to find help. If you've got something that's causing you some difficulties with loading your software, getting it to run, networking it, I would suggest you talk to our technical specialists and our technical support group. If you'd like to purchase a training class by attending it in Cincinnati or having one of our trainers come out to visit you, I would suggest you talk with people in our training department. And then finally, after you get your software up and running, you've used it for a while, but you've got one or two parts that are just driving you crazy. They're very, very difficult. Our applications department can help you with those because they use the software all the time. But in any case, you can call us at 513-367-7100, ask for any one of these three departments, and they'll be there to help you. Thank you very much.